Properties of inverse trigonometric functions. We have discussed first type, find the value of, then second type, simplify the given expression, and now third type is prove that. So let's start with the first problem. Here we want to prove that tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8 is equal to pi upon 4. So we want to prove this. So now what type is, third type is prove that. Now which property we can use here? It is very clear that we can make use of using which property? Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy, provided x into y is less than 1. This condition is important, xy less than 1. Now here you will observe that when you consider first two terms, you will have x is equal to 1 by 5, y is equal to 1 by 7, and you will observe that xy is less than 1. Similarly for the next two terms, 1 by 3 into 1 by 8, again it is less than 1. So we can straight away directly we can use this property. Okay, so using this property we get, so LHS is equal to, let's say LHS is equal to, we will be grouping terms, so we will consider tan inverse of 1 by 5 plus tan inverse of 1 by 7. So we get tan inverse of x plus y, so 1 by 5 plus 1 by 7 divided by 1 minus 1 by 5 into 1 by 7. Plus grouping next two terms, so we will have tan inverse of 1 by 3 plus 1 by 8 upon 1 minus 1 by 3 into 1 by 8. This is equal to tan inverse of, let's simplify, so 7 plus 5, that is 12 upon 35, and denominator will be 35 minus 1, that is 34 upon 35, so that will be into 35 by 34 plus tan inverse of, here you will have 8 plus 3, that is 11 upon 24 into 24 upon 23. Simplifying further, so we get tan inverse of, in the first bracket what we have is, this 35 gets cancelled, 12 upon 34, which you can simplify 6 upon 17 plus tan inverse of 11 upon 23. Now again using the same formula, since 6 upon 17 into 11 upon 23 will be again less than 1, so we can make use of this formula again. So this is nothing but tan inverse of 6 upon 17 plus 11 upon 23 divided by 1 minus 6 upon 17 into 11 upon 23. Since 6 by 17 into 11 by 23 is less than 1. This product is less than 1, so we can make use of this formula, same formula, right? Simplifying it further. So this is equal to tan inverse of, if you simplify it further, 6 into 23 plus 17 into 11, so you get 6 into 23, that is 138 plus 187, so 325. So here you get 325 divided by 17 into 23 into 17 into 23, now divided by 17 into 23 minus 6 into 11, 17 into 23 minus, so 17, that is 391, so you get minus you get 66. So 391 minus 66, so again you get 325 here. So this calculation is again 325. So everything gets cancelled and you get tan inverse of 1, which is nothing but pi upon 4, that is RHS. So we have proved LHS is equal to RHS. Okay. Let's proceed with the next one. Second problem. Prove that tan inverse of 2 plus tan inverse of 3 is equal to 3 pi by 4. Now in this problem, tan inverse of 2 plus tan inverse of 3. So if you apply tan inverse x plus tan inverse y formula, then x into y, here x into y is equal to 2 into 3, that is 6, which is greater than 1. Therefore, using tan inverse x plus tan inverse y is equal to, whenever this product is greater than 1, this formula is, or this property is, tan inverse x plus tan inverse y is pi plus tan inverse of x plus y upon 1 minus xy. Therefore, LHS is equal to, so LHS is equal to tan inverse 2 plus tan inverse 3, we are going to write as pi plus tan inverse of 2 plus 3 upon 1 minus 2 into 3, that is equal to pi plus tan inverse of, this will be 6 upon 1 minus 6, sorry 5 upon, this will be tan inverse of 5 upon 1 minus 6, that is minus 5. So you get tan inverse of minus 1. equal to pi plus tan inverse of minus 1. Now we have this property, since tan inverse of minus x is equal to minus of tan inverse x. Therefore, tan inverse of minus x is minus of tan inverse x. Therefore, we get pi minus pi by 4. This will be minus of tan inverse 1. So, this is nothing but minus of tan inverse 1. So, pi minus tan inverse of 1 is pi by 4. So, pi minus pi by 4, that is equal to 3 pi by 4. Equal to RHS. So, we got LHS is equal to RHS. Next one. Prove that 2 times sine inverse of 3 by 5 is equal to tan inverse of 24 upon 7. Suppose we start with the left hand side. We have 2 sine inverse 3 by 5. So we can write this as sine inverse 3 by 5 plus sine inverse 3 by 5. We want to have tan inverse of something, tan inverse of 24 by 7. So is it possible to convert both these terms? Is it possible to write both these terms in terms of tan inverse? Now, what do you mean by sine inverse of 3 by 5? Sine inverse of x is nothing but theta, right? So if I consider, let sine inverse of 3 upon 5 is equal to theta. What does this imply? That means sine theta is equal to 3 by 5. Then we can easily find cos theta using either identity. Cos theta is square root of 1 minus sine square theta. So using that you can get value of cos theta, or you can make use of the Pythagorean triplet. If you use Pythagorean triplet, suppose this angle is theta, sine theta is 3 by 5. So this side is 3, this is 5, and use the Pythagorean triplet. So 3, 4, 5. That means cos theta is equal to, so cos theta is equal to 4 by 5, right? And what will be tan theta? And tan theta is equal to 3 upon 4. So theta can be replaced. Therefore theta is tan inverse of 3 by 4. Therefore LHS is equal to, let's continue with the left hand side. Therefore we can say LHS is equal to, if I replace this sine inverse 3 by 5, this is theta, by tan inverse of 3 by 4. If I replace this with tan inverse 3 by 4, second term also tan inverse 3 by 4. So now again we got the form tan inverse x plus tan inverse y. What about xy? Xy in this case is 3 3s are 9 upon 16, which is less than 1. So using which formula? So again using tan inverse x plus tan inverse y formula. So this is nothing but tan inverse of 3 upon 4 plus 3 upon 4 divided by 1 minus 3 by 4 into 3 by 4. 3 by 4 into 3 by 4, 9 by 16, which is less than 1. So we have used this formula. That is equal to tan inverse of, so now here we get 6 upon 4. This will be 16 minus 9, that is 7 upon 16, that means into 16 by 7. equal to tan inverse of, we can simplify this further, 4 4s are 16 and 6 4s are 24, so we get 24 by 7. So tan inverse of 24 by 7, that is nothing but the right hand side. So LHS is equal to RHS. Okay, to find using value of sin theta, we can find cos theta or tan theta using right angle triangle method, that is using Pythagorean triplets, or we may use trigonometric identity. Cos theta you can write root square root of 1 minus sin square theta, so you can get value of cos theta. Once you get cos theta, you can find tan theta. Tan is sin theta upon cos theta. Fine. Okay. Let's proceed with the next one. Fourth one. Prove that sin inverse of 12 upon 13 plus cos inverse of 4 upon 5 plus tan inverse of 63 upon 16 is equal to pi. LHS is equal to. Now, like the previous problem, let's see whether we can convert first two terms in first two, that is sin inverse, in whether we can write sin inverse in terms of tan inverse and cos inverse in terms of tan. So we'll consider sin inverse of 12 by 13 as theta. That means we let sin inverse of 12 by 13 is theta. Therefore, we get sin theta is equal to 12 upon 13. So, can you find tan theta? Use Pythagorean triplet. So, tan theta will be using Pythagorean 5, 12, 13. So, tan theta will be 12 upon 5. Similarly, if we consider and cos inverse of 4 by 5 is equal to 5, then cos of phi is equal to 4 by 5. So tan of phi is equal to, we'll get 3 upon 4. So theta will be tan inverse of 12 by 5. So instead of sin inverse 12 by 13, I can write tan inverse of 12 by 5 here, and second term I can write, now here 5 will be tan inverse of 3 by 4. So this will be tan inverse of 3 by 4. Keep the third term as it is, 63 by 16 as it is. So we got all terms, three terms in the form of tan inverse. Now it's very easy to use tan inverse x plus tan inverse y formula. Now if I consider first two terms, then in this case x, here x is equal to 12 by 5, y is equal to 3 by 4. So the product x into y is it less than 1 or greater than 1? That we'll have to check. So this is nothing but 12 by 5 into 3 by 4. So we get 9 by 5, which is, therefore xy in this case is greater than 1. Xy is greater than 1. Therefore, using tan inverse x plus tan inverse y is equal to pi plus tan inverse of x plus y upon 1 minus xy. So let's use, therefore LHS is equal to, for the first two terms we are using this formula, so pi plus tan inverse of 12 upon 5 plus 3 upon 4 divided by 1 minus 12 by 5 into 3 by 4. And the third term as it is, tan inverse of 63 by 16 as it is. Simplifying further, so we get pi plus tan inverse so here we get 63 upon 20 into 20 upon minus 16, this will be, plus third term as it is, that is equal to pi plus tan inverse of minus of 63 by 16 plus tan inverse of 63 by 16. Further we know that tan inverse of minus 63 by 16 we can write it as minus of tan inverse, right? So this can be written as minus of tan inverse 63 by 16 plus tan inverse 63 by 16. So minus tan inverse 63 by 16 plus tan inverse 63 by 16 gets cancelled, so you get pi as the answer. So we got the right hand side. So LHS is equal to RHS. Converting expressions into tan and then proceeding using tan inverse x plus tan inverse y is the easiest way to solve such problems. Okay, let's try the next one. Here it is to be, we have to prove that, here we have to prove that cos inverse of 12 upon 13 plus sin inverse of 3 upon 5 is equal to sin inverse of 56 by 85. Now same way we can proceed converting all three expressions in terms of tan, because even right hand side also you have to convert in terms of tan. So instead of that, let's see whether we can have some other technique for this problem. So let's consider, let cos inverse of 12 upon 13 is equal to theta and sin inverse of 3 by 5 is equal to some other angle, say phi. Therefore, cos theta is equal to 12 by 13 and sin phi is equal to 3 by 5. Now using Pythagorean triplet or using trigonometric identities, we can easily find sin theta here. In this case, sin theta will be 5 by 13 and cos phi here will be 4 by 5. Fine. Now because of our assumption that first term is theta, second term is phi, so exactly what we want to prove? So we want to prove that, now first one we have considered as theta, first term as theta. So we want to prove theta plus phi is equal to sin inverse of 56 by 85. This we want to prove, right? Or sin of theta plus phi is equal to 56 by 85. So here we'll consider, so let's consider see, right hand side is sin inverse of 56 by 85. So I have considered sin of theta plus phi. Let's consider formula for sin theta plus phi. This is equal to sin theta cos phi plus cos theta sin phi. Now substituting all the values we get, so sin of theta plus phi is equal to, let's substitute value of sin theta. Sin theta is 5 by 5 upon 13. Cos phi is 4 by 5 plus cos theta, value of cos theta is 12 upon 13 and value of sin phi is 3 upon 5. Simplifying all this, so we get sin of theta plus phi is equal to, so we get 56 by 65. 20 plus 36, so we get 56 upon 13 into 5, 65. Okay, therefore sin of theta plus phi is equal to 56 by 65. Therefore we can say that theta plus phi is equal to sin inverse of 56 by 65. Therefore, but what is theta? We have assumed that theta is equal to, this was our assumption, that cos inverse of 12 by 13 is theta. So cos inverse of 12 by 13 plus phi is sin inverse of 3 by 5. So plus sin inverse of 3 by 5 is equal to, we got it as sin inverse of 56 by 65. That's what we wanted to derive. That's what we wanted to prove. Okay, and the other method is converting all three expressions, all three terms in terms of tan inverse and then using tan inverse x plus tan inverse y formula. Next one. Prove that sin inverse of 3 upon 5 minus sin inverse of 8 upon 17 is equal to cos inverse of 84 by 85. You may convert into tan inverse and then proceed, or the method which we have used in the earlier problem. So let's use that similar method which we have used in the earlier problem. So here we are going to consider, let sin inverse of 3 by 5 is equal to theta and sin inverse of 8 by 17 is equal to phi. Therefore we get sin theta is equal to 3 by 5. So cos theta will be 4 by 5 and sin of phi is 8 by 17. So cos of phi will be, use the Pythagorean triplet. So cos of phi will be 15 upon 17. So using these assumptions, what we have is, therefore now sin inverse 3 by 5 I consider theta. So theta minus 5 is equal to cos inverse of 84 upon 85. So our problem is like this. We want to prove that theta minus phi is equal to cos inverse of 84 by 85, or cos of theta minus phi is equal to 84 by 85, right? So in this case, what you are going to consider, next step will be, let's consider. So this we want to prove, right? So let's consider cos of theta minus phi. Now expansion for cos theta minus phi is cos A minus B formula. Cos theta cos phi plus sin theta sin phi. Substituting these values, so we get cos of theta minus phi is equal to cos theta, value of cos theta is 4 by 5, cos theta is 4 by 5 into cos phi is 15 by 17 plus sin theta is 3 by 5 and sin phi is 8 by 17. Therefore, cos of theta minus phi is equal to, simplify this further and you get, yes, 60 plus 24, so 84 upon 85. Therefore, theta minus phi is equal to cos inverse of 84 by 85. That's what we wanted to prove. So we have proved that. What was our theta? Theta was sin inverse 3 by 5. So sin inverse of 3 by 5, sin inverse of 3 by 5 minus sin inverse of 8 by 17 is equal to cos inverse of 84 by 85.